Hi, everybody. I think first up is Yi, unless there are any other. Do we have any new people that I don't know before? Well, if you're new, if it's the first time you want to introduce yourself, raise your hand. Niels?
Yeah,
Sure. Say
Hi,
hello.
I'm Thomas, part of the Freenome engineering team, and also this weekly user of Flyte, and hoping to hopefully contribute back, but also learn more from the community. Nice to meet everyone.
Welcome.
Welcome, Thomas.
Hey, yeah, I just want to introduce myself. Happy to be here. My name is Niels. I'm a ML engineer at Talkspace, but I guess I'll talk in a little bit about Pandera, which is a project I've been maintaining.
Yeah, thank you for doing this on such a short notice, Niels.
No problem.
Hey, so I guess I can get started. We were hoping to, let me stop my video. That's a weird thing anyways. We were hoping to cut a release last night. I think that got delayed until this morning. I think we will try to do it right after, or at least shortly after this meeting. This is going to be the second, I guess, alpha release of the new Flyte Kit API. There's obviously less stuff than the first release, and I think if people, I don't think we're stuck to the strict moniker of the naming of the version, so if we find bugs, I think we're going to start cutting smaller patch releases as well. But in any case, in this release, there are a few things that we wanted to go over. The first of which is Hive. Hive, as you know, if you don't know, is strangely handled currently on the master branch. This is how it works. If you see on the screen, that we basically have a couple utilities that that wrap the user query in a template, and that final query is actually what is executed on the backend. And there's a couple of differences between how Presto and Hive behave when this new latest model that I'm talking about now is what Presto eventually will be moving to, which is kind of irrelevant because we don't have a Presto client currently in open source, but hopefully in the near future. So instead of having preordained wrapping templates like you see here, this is basically a templating that will run a user select query, but then write the outputs to a specific location that is known to Flyte. So instead of doing this, we've introduced, you can take a look at all these later. We've introduced things like this in the past. This was initially only for Presto. We are now enabling this for Hive, or this has been enabled as of the latest plugins and Propeller. And users can construct whatever. So if you look here, this is the insert one, there's another one for write. And it never really made any sense for us to do this. So users can now write Hive queries in the new way, which will be, I wrote a little, this is not yet checked into the cookbook. We will do that shortly as well. But this is an example that shows the templating fields that you get, I guess. So you can use this for creation of a temp table. This is where your output data should be, and then input schemas you can refer to if you are, this is applicable to the write case here. Input schemas will just get extrapolated and interpolated into, like, with their URI field. We have also introduced, this is a major sticking point in the older Flyte kit, multiple image support. So if you specify a configuration like this, you will be able to control, I mean, the user is still responsible for making sure that these images exist, but you can run tasks with, I think I have a better example of it. If you do this, you will now be, well, hang on. That was not the example I wanted. Well, in any case.
Do you want me to explain this one?
Sure.
So the problem statement here is that it's currently felt by many users that Flyte only supports one container image, but that is not true. The container image binding is per task. And that is by design, because when you're working locally, it's very easy to install all your dependencies into one virtual environment and work with your entire project. If you're using Python, if you're using Java, you can do the same. But when you're running remote, in the model of Flyte, you want to actually package not only your dependencies, but the runtime system while you're deploying. So for example, if you want to run an algorithm on a deep learning model on GPUs, or if you want to run a Spark job. If you want to run something on GPU, you need NVIDIA drivers. If you want to run a Spark job, you need Spark jars and an entry point that's specific for running Spark. Like if you, I don't know if you've ever used SageMaker, but if you use SageMaker, then you need another entry point for SageMaker, and it needs, if you're using distributed training, then you might need Harvard and OpenMPI setup. So this setup, which is actually not really usually part of the user's journey when they are running it locally, when you are actually running it in production, it becomes complicated. And if you could get away with just building one complicated image for everything. Now the problem with that is the build times increase, the sizes of the image increases, which also affects the runtime. Just generally large images are not very useful. Along with that, they had added complexity of making all of them work together in one image. So to avoid that problem, a simple solution is to use multiple images, one per task. But then the real problem with that until now was the UX for this. So we've now proposed a new UX when you're working with it in FlyteKit. By default, if you have a workflow with multiple tasks, then it will use the same default image if you don't specify anything. But if you want to override that and create a new image, then as he's showing over there in task T2, you can say, hey, instead of the regular container image, use this container image. And the container image here is parameterized using the same templating system that's been used throughout FlyteKit. So one of the default image is called image.default. And the FQN is the name of the image, which includes the repository like docker.io /flyte.org/xyz. And then the version is actually the tag on the image. And so you can combine those two together to form a fully qualified image name with the version. Now, if you don't specify both of them, then this is, as you see in T2, is the actual final version that will be applied to the container image. But as you can see, because these are parameterized, you can actually change any one of them. For example, in the next one, you just used some docker.io, like in T4, you're using a docker.io image. In T5, you are actually using the FQN which is constant, but the version is supplied at the runtime. And the version, now, if you have used FlyteKit, what we are recommended and we recommend everybody do is use the version as the git hash or the git SHA. And so in this case, what's essentially happening is when we're building the images for this repository, instead of building one image, we're building multiple images and tagging them with the same git SHA. In the cookbook, which is a better place to show all of these examples, we have what we've done is we've used the same image with different tags, and the difference is that the tags just have a separate appendix in the end, like so. If you that's Spark hyphen. That's it. So basically, the tag is the same. So the name of the image is the same. The version is kind of the same except for one prefix. And so what this allows you to do is write the code locally, have all your dependencies locally, make it run locally as is. But when you're running it remote, use the benefits of having different images and with minimal overhead, hopefully. So, and then example for all of this exists in the code.
Cool. Thank you. We've also added, on a completely different note, Sidecar tasks are now in the new API as well. We will have, I think we already do have the codebook example for this, and the type engine has been extended to support a subset of data classes, namely data classes that are also data JSON serializable. So you have to decorate with both data class JSON and data class. So there was some initial discussion about, I think from Hongshen, to use data classes as a mechanism by which users can specify output, like custom output names of tasks and workflows. We decided not to go with that approach because then we would have to differentiate between when a user actually meant a custom data class type and when a user meant just to name the output. So for the sake of clarity, we decided to go with just letting users use this only for custom types. But now tasks like this will work. And Ketan also made some changes to Spark data frame handling. And also, do you want to talk about the new Flyte kit gallery, I guess, or Flyte snacks gallery?
I guess you can show that, but I'll talk a little bit about. So the data class JSON is a separate library that comes with Flyte kit if you enable the data class plugin. What that essentially is trying to solve is handling support for arbitrary data types, user-defined data types, and like Flyte supports dictionaries and Flyte supports JSON values being marshaled and sent through the system. But the UX for it is basically what we've decided is to use data class. One of the things that I wanted to add to what he said is why we did not decide to go with Onyx's recommendation of using data classes as the return variable naming system is because exploding a data class into a tuple, because let's say on the left-hand side, you are trying to receive multiple parameters, kind of not really idiomatic Python. So it would look odd when you're returning a data class and we're exploding it into multiple variables. Instead, returning a name tuple and exploding it into multiple variables is very idiomatic. And that's one of the reasons why we decided to take only name tuples and keep this way. If you, do you want to actually scroll down a little bit? So this is the Flyte snacks update. Essentially, all the code written in Flyte snacks is now written in the format of literate programming. So code has code and comments all in line. And as we publish new examples and hopefully we document them very well, they will automatically generate this docs along with the code. All of this code is runnable locally with Flyte kit. You can also download all the code, look at it. It also allows you to get a IPython notebook, and we'll soon be adding binder support. So then you should be able to run everything in binder as well. If you go back. Yeah, and of course, this is all published to read the docs. Now in here, there's an example in the intermediate section. What we've done is we've also laid out examples in 3 sections. So beginner, intermediate, and advanced. So if you're getting started with Flyte, it's better to start with beginner. You can start, it's laid out in a serial order in which if you read the examples or try them out, you should ramp up on Flyte pretty quickly. And going to intermediate is once you've understood all the beginner concepts and tried them out, you might have questions and we try to answer them in intermediate. For example, one of the things is how to run conditions or how to use schemas, and those are all given as examples over here. The cool thing is, as the documentation it generates, if you mark them specifically, it also captures the output of that execution. So we are constantly running those examples in docs and capturing the outputs. If you go back for a minute, yeah, so the number, I'm trying to understand which one. So you can open up number 3, I guess. So this example shows how to use Spark. But in this case, it's even more interesting. What's happening is actually the task number 1 is actually generating a Spark data frame that matches the schema construct or the schema definition declaration of Flyte. And you just return the Spark data frame. And if you look at task number 2, it also accepts a schema, but you open it, and the default open of the schema returns a pandas data frame. You can parameterize it to return like other types of data frames. To currently only Spark data frames and pandas data frames are supported. This is a loadable module where you can add more plugins, and we want to add different other types of data frame technologies like wakes and sorry, I'm forgetting a couple of them, but there are a few of them available. So the interesting part to note over here is that you can take a Spark data set or data frame and retrieve it as a pandas data frame in a subsequent task. And this happens completely transparently. This is possible because Flyte's representation of data frames is abstract. It does not really care that the data is a pandas data frame or a Spark data frame. It transforms from those data frames to a centralized representation, and then using that representation, it can transform to any other format. So you should be able to read it from a PySpark data frame definitely into a Spark Java data frame, as well as if there is a Java data frame technology, which is besides Spark, you should be able to read it into that, as long as it can, let's say, read from Parquet or some other formats. So that's one of the things, and this is achieved by using type transformers that we talked about some time ago, and I think Niels will probably give a little more demo of how he used it to write Pandera integration, which actually makes this data frame system even better, I think. Please go through this and ask questions because it's a little complicated. I think once you try to use it, it hopefully simplifies everything. It's complicated to explain, so would love feedback on this.
That was it for the changes, I think.
Sorry, what?
That's it for the Flyte kit changes.
Yeah, and we should have this alpha out soon. Actually, the alpha code is ready. It's like we were trying to do the examples and how to represent them out. And so that's why we use this new plugin in Sphinx.
Wait, I think I forgot to mention the conditionals have been fixed on all sides, so they will now fully work, pending one more PR from Haytham.
Perfect. Who's next? Niels?
You're muted, George.
Changhong is next on the agenda, but I think we ought to go with Niels because we're probably going to run out of time because that went a little bit long, and I'd like to see Niels' stuff since he's new. So I think Niels gets bumped in before we hit our limit, and then we'll deal with
thank you.
Rebouncing the limit. Sorry, Changhong.
Sorry, I might need permission to share. I'm not seeing where I can. Oh, oops. I should have figured this out before the meeting, but
it's at the bottom of the screen.
Like my computer needs to.
Oh.
Yeah, I need to restart my Zoom to be able to actually share my screen. It's weird.
So while you restart, maybe Changhong can go.
I think, okay, you can ignore that notification. Just try to share again. It's a Mac, right?
Yeah.
Yeah.
Okay. I think it said something like I won't be able to
Yeah.
They won't be able to share.
It lies a lot. Yes.
Okay, so everyone can see this. Just my editor and stuff. Okay, great. So just a little bit of a background on Pandera. It's basically a runtime data validation library for pandas, although in the future, we are planning on supporting things like Dask and Spark via the Koalas API. But in any case, the way it's kind of evolved, but sort of the interface, there are basically two ways of expressing schemas in Pandera. Here I'll just show the newer, shinier version of it. So basically, I have an example here of how you would use Pandera in concert with Flyte. So at the top here, I've defined 3 schemas in sort of like a 2-part pipeline. So the first schema is the input schema, which has 2 columns. And we can leverage an inheritance in Python here to say, process that data to an intermediate schema that has total pay. And this is kind of maybe inefficient or superfluous, but this is a custom check that Pandera enables to just make sure that total pay equals, hourly times hours worked. And then this is also kind of a trivial example, but the final output has some kind of worker ID attached to the data. So the way I've threaded this together in Flyte tasks is I have 2 tasks, total pay and add ID. And the way in Pandera you check the types of like the inputs is we're just going to use the type annotation of Python. And this is kind of a special data frame that Pandera has where you can like specify a schema with the syntax. And it's all put together in a workflow. So I have some, this is like a toy example where I have the initial data here, and I call total pay and add ID. And just to show you that everything works here locally, I'll just run this example, and at the end of the workflow, I get this data frame. So if I, for example, mess up the computation, so if I say if I just add those 2 numbers, Pandera should complain with informative error messages saying what the failure cases are, what the column and indexes are. So this is like one of the primary value adds of Pandera is when things fail, they fail early. And this is actually, with a few more lines of code, you can actually get access to this entire data frame with all the failure cases, and so it makes kind of debugging easier. So I don't know, I'll spend a little bit of time, I guess, on what the integration looks like. So in this Panda schema module in Flyte, I basically created this Pandera transformer here. A lot of the stuff is duplicated from the pandas or the Flyte schema transformer. So maybe not the most dry implementation, but at the bottom, I just register the pandas transformer or Pandera transformer. Initially, I was going for an interaction like this, where all I have to do is import Pandera and like Flyte should be able to know about the Pandera data frame over here. But that doesn't really work because it doesn't know that the type is registered. Oh, huh. Okay, that worked. I have no explanation for that. Okay, scratch that last comment. I don't know why this is working, because before, oh, there you go. Okay, I didn't say that.
I think it existed. Your bytecode is older.
Yeah. Great. So this is what I was going for, where you just kind of, if you know about Pandera and FlyteKit, you can have both installed, and it'll automatically know that the Pandera data frame type is a thing. but for now, to get this working, I just have to import it from the types module in this way. So I guess with that, I'll end and open up the discussion for, how to actually write these kind of third-party plugins.
Yeah, I had a question about that, Niels, actually. So do you have a better way of loading those? We would love any ideas that anybody has of how we could, lazily but yet dynamically load these type plugins. There's another place where we had the same issue, actually. It's in our docs where you have to import something just to make the pandas data frame transformer work. And you put an OQA check at the end. But if there is something, we would love all ears.
Yeah, I don't know.
Yeah. The beauty of lazy import is that this allows you to add plugins dynamically, but the sad part of lazy import is that you have to import it. Right? So, this looks awesome, though. I think just shout out to Neil. Basically, he completely implemented this on his own, like in some very little amount of time with zero help from us. So thank you. And I actually looked at Pandera, and I'm like, it's the best UX essentially, according to me, to define data quality checks on data frames within in Python. It probably is one of the best, and I'm hopeful that we will continue to work together and integrate it and make it even better for all the users.
Great.
Do we want to talk about where? Yes, thank you, Niels. But did you want to talk about where to put this, Ketan?
Yeah, should we open up that right now? Yeah, sure. Do you guys want to kick it off?
Sure. We only have 5 minutes, I think, remaining for this section of the meeting. But basically, the issue is that it's while having Pandera is fantastic, having like 10 different Pandera-like things all in Flyte increases the bloat of Flyte. So we are thinking about a couple options. We can leave it there and just deal with it. We can force Flyte into Pandera, which isn't ideal either. Or more acceptable probably is creating either just a Flyte Pandera separate repo entirely, where that would get loaded and users would explicitly have this dependency in their requirements, or have a Flyte plugins repo where all of these plugins would go, and you can just bracket select the ones that you want. I think those are the options that we were thinking. I'm not sure if there are others, but if Niels or Ketan or anyone else has opinions.
Yeah, so Pandera Flyte doesn't need a separate repo. It could be part of either of the repos, just a separate package in PyPy, right? That's what you're saying.
Sure.
Yeah. I actually think that the separation of modules is the best. Like when we started, we just decided to use the bracketing thing in setup tools, but it kind of bloats quickly. So, but I'm open to suggestions of what people would love. Like in my opinion, it's the same, right? Whether you create one repo with all the packages or let people have those packages published independently, it does not matter. Now the problem with independent publishing, in my opinion, is discovery. Like how do you really find all the plugins and how do you install them? And that might be solved using documentation, or having a central repository probably solves that, but it also increases the like the check-in commit problem where you're like, hey, I have a commit and I'm completely different. I'm Pandera, I'm TensorFlow, I'm whatever. So that's kind of a problem. But my two sides of the same coin, essentially. Anybody has any ideas, recommendations? There's nobody. Usually Jeep would have an opinion on this.
Yeah, I was going to say +1 to the Flyte plugins repository, just to kind of keep things consistent, I guess, since you already have like a Flyte plugins repository.
Yeah, and we can actually make it so that there are multiple setup files, right?
Mm-hmm.
Yeah, I think that would be a great place to start, I think.
And you would like publish multiple packages from that. There could be a package per plugin from that one repo. Okay.
I would actually even move Flyte Spark and all of those things.
Yeah, that would be ideal. Yeah, we'll move all of those TensorFlow, PyTorch, all of these into that. Yeah.
Oh, to that front, I had some news. I think we never talked about that in the agenda. So Flyte's moving to Linux Foundation. It's getting donated to Linux Foundation. We still don't know the exact home, whether it's Linux Foundation AI, and data, and all of those things. But we are in talks, and I think it's all approved from lib side. It's just we're deciding the final destination. And so some of this stuff might happen after the move, just because all the repos and everything, making them it's so much easier in there, and All right, it's less than a minute. We're going to restart and let Changong continue. And I don't know how to solve this 40-minute problem with Zoom.
You solved it with a credit card. I think I just solved it.
But it says less than a minute still.
Shouldn't.
Your screen is still shared, Niels. Just FYI. Okay.
Well, we'll see if it actually kicks us out, because I just created to a paid account. So if it does, all you have to do is restart the same meeting, just re-click on the URL, and it'll come back to life.
Okay, Changong, do you want to start? Do you want to go?
Sure. Give me 1 second. Share screen. All right. Can everyone see my screen? Okay, cool.